Chapter 6, Inverses, Radical Functions and Relations. We're going to start with Section 1, Operations of Functions. So this lesson is all about all different operations we can do on functions. All the basic ones, and then a couple of the more advanced ones. So let's talk about a couple of the basic ones. So you can add two functions, right? If they want you to add a function, they'll give you this symbol, f plus g of x. This means add f and add g. And they show the example right here, f of x equals this, g of x equals that. Hey, they want you to add them, just add them up. Subtraction is the same thing, right? So if you see f minus g of x, it's f of x minus g of x. And this one you want to make sure you put parentheses. You just subtract them. This is the multiplication symbol, so you just multiply the two functions. And then this is the division symbol, f over g of x. This means, hey, divide the two functions. Something new we're going to add in this lesson is how to do domain given a function. So we did it with the graph, we did it with the table, all this other stuff. Now we're going to do it with the function. And this is a general idea of how we do domain. You want to think about numbers you can plug in. Sub in to be more accurate. So, see if we have a fraction here? If you think about a fraction, what's the one thing you can't divide by? You can't divide by 0. So x cannot equal 0. So anytime you have a fraction, you just set the bottom equal to 0. And that's what they did here. If you look at their negative x plus 5, set that equal to 0 and you solve it, add the x both sides, x cannot equal 5. So anytime you have a fraction, you can't divide by 0. If you think about a square roots, we can't have negatives, so x has to be greater than or equal to 0. And that's the only thing we have to worry about right now. Everything else is all real numbers. Because there's no issues, right? If I give you something that looks like this one right here, I can plug in anything I want. There's no fraction, there's no square root, all real numbers. So look at that one. I can plug in anything I want. My domains, all real numbers. My domain here, all real numbers. My domain here, all real numbers. Only when there's a fraction or square, I got to think about it. Oh, it's not all real numbers. In this case, it's x not equal 5. So all real numbers, also known as that fancy R. So that's our domain. So when I ask you about the domain, you just look at is it a fraction, then the bottom cannot equal 0. Is it a square root? Then inside the square root has to be greater than 0. If it's anything else, as of right now, we'll add more later, but right now it's all real numbers. So let's do some examples. So they want us to do every single one of these for this one. So they want us to do f plus g of x. They want us to do f minus g of x, f times g of x, and f divided by g of x. And if every single one of them, they want to indicate the domain. We're not going to do the range. We'll do domain. Range we'll learn next here. So f plus g of x. So f is x plus 2. G is x 3x minus 1. They're supposed to be different colors right now. So f. So remember, this just means add up 2. So we're going to add x plus 2 plus 3x minus 1. All we do is add like terms. Right? The parentheses don't mean anything because there's no numbers outside. So I get 4x, and then 2 minus 1 is 1. That's my answer. That's what f of g of x equals. Now keep in mind, I see a lot of people do this. That is not what's going on. Like, you don't multiply by x at the end. What the x means is, all the x means is what is your variable. That's it. If this was f plus g of w, only thing I would change would be a 4w plus 1. That's it. That variable just means, hey, what's the variable that is? If that's a number, you plug in the number in, right? This is what gets plugged in, not what gets multiplied by. So you plug that thing in. So that's the way that works. By the way, my domain, no fraction, no square root, so all real numbers. Do a fancy R. Next one, f minus g of x. Again, that just means what variable we're using. So in this case, we're going to do f minus g of x. And this one, you got to watch out for the parentheses because it's like a negative one, you got to distribute. So you get x plus 2 minus 3x plus 1, negative 1 times negative 1. Add like terms. Add it correctly, almost messed up there. Negative 2x plus 3. And my domain, again, no fraction, no square root, real numbers. Next one, f times g. So we're just going to multiply them. X plus 2 times 3x minus 1. Distribute, so 3x squared minus x. Distribute, 6x. Distribute, negative 2. add like terms. There I go. My domain, again, no fraction, no square root, so all row numbers. And the last one's the easiest, but we have to worry about the domain here. F over g, so f is x plus 2 divided by 3x minus 1. So that's my function, but there is a domain here where I have a fraction. So for the domain in this part, you always do the exact same way. I have a fraction, you set the fraction not equal to 0. And we just solve it. So we add 1. 3x could not equal 1 divided by 3. So my domain is x cannot equal 1/3. So there we go. Right? So all we do is follow the instructions, right? Don't, keep in mind this does not mean multiply, it means what are you plugging in? Plugging in x. I'm plugging in x. And then we take the domain. If it's, the only thing I worry about right now is fraction and square root. That's it. If you don't see a fraction and square root, it's all row numbers. Okay, let's move on to the next one. Let's have some fun here. Let's do f minus g of w, and let's do f plus f of 3, and then let's do g over f of x. So the first one, f minus g, so now f is this, there's a w there, so I actually got to put w instead of x squared, so w minus 5 minus g, which is negative w plus 8. Alright, that's all that means. Hey, I'm going to change my variable. That's all that means. Then we distribute the negative, w squared minus 5 plus w minus 8. Add like terms, w squared plus w minus 13. My domain, no fraction, no square root, all row numbers. The next one, f plus f. So this one I'm going to do a little differently. So we'll just do f plus f. So f is x squared minus 5, and f is x squared minus 5. Now let's plug in the 3, because that's all that means. You plug it in. So 3 squared minus 5 plus 3 squared minus 5. I get 9 minus 5, so 4. Same thing here. So 4 plus 4 is 8. Now I don't have to do domain range, we just have a number. So we got a value. We didn't get a function. Well, it's a constant function, but it's a different problem. G over f, so we're going to plug g over f. So negative x plus 8 over x squared minus 5. Now I want to find a domain. All we do, so the denominator not equal to 0. So x squared minus 5 does not equal 0. Add it. Square root it. X should be not equal. Cannot equal plus and minus rad 5. So that's my domain. It can't be negative rad 5 or positive rad 5. Either way, I get a 0 on the bottom, and we can't divide by 0. So that's the idea with those. We do the same thing with the example real quick. Application problem. A ceramic store manufactures and sells coffee mugs. The revenue from a sale of coffee mugs is given by Rx equals 6.5. Suppose the function of the cost of manufacturing mugs is this. So they give you revenue and cost. Remember, revenue is how much you make. So it's like money in plus. Cost is how much it costs. So money out minus. What's a profit function? This is actually the whole reason I want to do this problem. So the profit function is always the same. It's revenue, money you make, minus the cost function, money you lose. That's a profit function. So if they're asking for profit functions, it's revenue minus cost. So in this case, my profit function is Rx minus Cx. And then they want you to find a profit at 500,000. We're just going to plug it in. So it'll be R 500 minus C of 500. A lot of that's just putting in your calculator because it's going to be 6.5 times 500 minus parentheses 0.75 times 500 plus 1850. Right, these put in your calculator, get an answer, and you get the profit. You can do the same thing for the rest. But the key thing about that is I want you to understand what a profit function is. Profit is just money you make minus money you lose. That's how you find your profit. Okay, now let's get to the big thing for this lesson. Composition of functions. Composition of functions. So this is the whole idea of this is you're going to plug one function to another function. As you can kind of see here, f of g. So if you see this, now it's different than this. Right? That means multiply. You see a closed dot means multiply. This is of, which is composition. Which means you're going to plug, it's f of g. You're going to plug g into f. That's you kind of see it right here, right? G's inside the f. So it's always like that, g of f. So you can plug the g function into that function. And it's always best to do a few examples to show you. So in this first one, they want us to do f of g of x, and they want us to do g of f of x. So here's f of x. Here's g of x. And then the way we do this is always the same way. We're going to plug inside into the outside. So I always ask, what's the outside function? Our outside function is f, so write it. So f is -3 times something, right? That's what f is. We're going to plug g into that. Right, so the outside function, f, is -3 something, and then we're going to plug g into that. So what is g? G is this thing. We're plugging that into the x right there. So it's going to be 5x minus 6. Then we distribute -15x plus 18. That's what f of g of x is, right? We're plugging g into the f function, plugging all this into that function right there. Domain, no fraction, no square root, all real numbers. Next one, same idea. We're going to plug f into g. So I can figure out what g is. G is this thing, so write it. 5 times something minus 6. And then we're going to plug the f function into there. My f function is -3x, so just plug in -3x, distribute, -15x minus 6, and that's it. Again, domain, fraction, no square root, all real numbers. So you can plug anything you want there. That's how we do f of x and g of x. Ah, that's the next one. Again, let's have some fun. Let's do f of g of w, just to show you the function. And then let's do g of f, but we won't simplify it all the way. And then for fun, let's do f of f. So f of g of w. So again, we're going to plug g of w into f. So figure out what this is. This is just x plus 4. And we're going to plug g in. So all this mess. Out of like terms, get x squared plus 3x minus 6. My domain, no fraction, no square root, all real numbers. That's supposed to be an r. G of f of x, right? We're going to plug f into g. So write out what g is. G is this mess. This whole thing. And then we got to plug f into it. So let's plug in f. F is x plus 4. We're plugging into every single x we see. So x plus 4, x plus 4. Now, I wasn't stop there, but we can do this. Remember, x plus 4 squared. Don't give me x squared plus 16. Remember, that's x plus 4 times x plus 4. We'll apply it out. Hopefully you get faster at that. It's x squared plus 8x plus 16. 16. Distribute that, you get 3x plus 12 minus 10. Just out of all the like terms, that's going to be 2 plus 16 is 18. So x squared plus 11x plus 18. Domain, again, no fraction, no square root, all real numbers. Last one here, before we get to some different ones. F of x. So we're plugging f of x into itself, little inception thing going on here. F is x plus 4. So again, let's write it. It's like this. Right? That's what f is. And in this case, we're going to plug f into itself. So let's plug f of x in there. F of x is that. We got like terms, x plus 8. Domain, all real numbers. So that's composition of functions. One of the big ideas of this chapter. How do you do composition of functions? Now let's do it with numbers. Like most things in mathematics, there's 2 ways to do this. I'm going to show you way 1 first. Way 1's the way we've been doing it. So g of h of 3, so let's plug h into g. G is this, so -2 times something plus 1. Then we're going to plug h in. h is that mess. That did make life easy on myself. X squared plus 6x plus 8. Distribute. Why did I make it so hard on myself? And I get negative 2x squared minus 12x minus 15. And then I haven't idea with the number yet, right? 3? Now we just plug it in. So plug in the 3. So negative 2 times 3 squared minus 12 times 3 minus 15. This is 9. So negative 18. Oh, I hate myself. Negative 36 and negative 15. That is negative, what is that? 36 plus 15. 56, 51. 51 plus 18. So that's 69. Negative 69. So you get that. That's way 1. Right? You just do like you normally do it, and then at the end you just plug in the number. So that's the first way of doing it. That's actually not my favorite way, if you couldn't tell. My favorite way is this. Let me erase this real quick. My favorite way is work inside out. Do the inside first. Let's just figure out what h of 3 is. Let's do this first. So h of 3 just means plug 3 into h. So it's 3 squared plus 6 times 3 plus 8. So 9 plus 18 plus 8. So 26, 35. Right? 26, 35. Yeah. So 35. So all that means is h of 3, that's 35. So now we have leftovers g of 35. So do that. We're going to put 35 into g. So negative 2 times 35 plus 1, negative 70 plus 1, negative 69. So see, either way you get the same answer. I prefer way 2 myself. Should label them way 1, way 2. But way 1's the same thing, right? You just simplify it and then you plug a number in. So let's do another one to practice. Let's do h of g of 2. So again, I'm going to do g of 2 first. So it's going to be g of 2 is going to be negative 2 times 2 plus 1. So negative 4 plus 1. So negative 3. So that just means this is negative 3. Now you do h of negative 3. Plug it in. Negative 3 squared plus 6 times negative 3 plus 8. So 9 minus 18 plus 8, negative 10, negative 1. So that's how we do composition functions with numbers. You can either simplify without the number, pretend the number's not there, and then plug in your number, or work your way inside out. So let's move on. Let's try this one. Okay, so the way this works is this. We're gonna do composition functions with given points. Let's do f of g of x, like this got highlighted up there. Now, what this means is we're gonna do. It probably looks a little easier if we write the other way. F of g of x. That right? So we gotta pick a value in g. Let's start with the first one, 6. So we're gonna go up here and we're gonna put f of g of 6. Right? So we gotta do g of 6. So what's g of 6? Well, 6 gives you 8. So g of 6 is just 8. Now we need f of that answer. What's f of 8? Look at f. 8 gets you 12. So 12 is my answer. Let's do another one. Let's do f of g of 0. Alright, so again, we start with the middle one. What is g of 0? G of 0 gives you 5. So that means this part's gone. That's just a 5 now. So all I'm asking is f of 5. F doesn't have a 5. So if they exist, this one does not exist. So you can't do f of g of 0. It does not exist. But we could go backwards. Let's do g of f of negative 7. Right? So again, do that one first. F of negative 7. Look at f. Negative 7 gives you to 0. So this one's 0. Now we just gotta do g of 0. And g of 0 goes you to 5. Such as this 5. So that's how you do it. Composition when I give you points like this. You just work your way. Let's finish off by doing a couple of advanced problems. So this first one. So first thing I want you to notice, f times g. See how it's closed? So that's a times. This is composition. So this is f times g times h. So first let's write it out. So that's going to be x plus 2, that's my f, times g, which is negative x plus 3, times my h, which is x squared. I'll have h, 2x plus 1. Right, you can multiply these out and then plug a 3 in. So one thing you don't want to do is just multiply them all out together. It'll take forever. Plug a 3 in first. So plug 3 in, get all those values, then multiply them together. Makes it a lot easier, right? Because that's all we're doing here is we're multiplying them and plugging in 3. So plug 3 in first. So I get 5 here, 3 times 2. Negative 12 plus 3, so negative 9 in the middle. And over here I get 9 minus 6 plus 1, so 4. So I get 20 times 9, negative 9, so negative 180. All right, a lot simpler. It takes a lot less time than multiplying it all out first. Just plug it in, multiply them all together. And then over here we have g of h of f. So see how there's 3 of them? Well, same process. Work your way inside out. So do f of negative 4 first. So f of negative 4 and plug negative 4 into f. So negative 4 plus 2, so negative 2. So this part's done. That's just negative 2. Now h of negative 2. So negative 2 squared minus 2 times negative 2 plus 1. Which is going to be 4 plus 4 plus 1, so I get 9. So all of this is done. Now it's just 9, g of 9. G of 9, and g is this equation. So negative 4 times 9 plus 3, negative 36 plus 3, negative 33 is my answer. All this is just negative 33. That's the lesson.